Hello, we're on 6.05 today, and we're going to talk a little bit of a shorter lesson today on vectors and talking about if they are orthogonal or parallel. So, first of all, orthogonal is just another word for perpendicular. So we're seeing if these vectors are perpendicular or parallel. So to see if they are orthogonal, so vectors u and v are orthogonal if the dot product of those two vectors is equal to 0. And just so you kind of have a little insight as to why that is, the reason would be because your dot product from our formula, when we're finding the angle between two vectors, if I were to solve for the dot product, I would get the magnitude of u times the magnitude of v times the cosine. Now, if they're orthogonal and they're perpendicular, that means they form 90-degree angles. And the cosine of 90 degrees, we remember up here, the ordered pair for this point is 0, 1. So the cosine, which always comes first, would be 0. And 0 times anything is just going to be 0. So that's why the dot product has to be 0 if they're orthogonal, because it means they're forming a 90-degree angle. So again, this formula just came from our formula for the angle between two vectors, and I solved it for the dot product, just so you kind of understand why this works. Now, vectors u and v are going to be parallel to each other if one vector is equal to the other vector times a constant number. So it would just be the dot product equal to the product of your magnitudes, because the angle between them would be 1. The angle between them would be 0. I'll write it out for you. Again, you don't need to be able to show me this in parentheses. I'm just telling you this so it helps you to understand where it's coming from. So if we have them parallel to each other, then they'd have an angle of 0 degrees. And 0 degrees has the ordered pair 1, 0. So the cosine is 1. So we're just taking one vector and multiplying it by something else. And this one's a little bit more self-explanatory without seeing this, I think. But you are just taking one vector, multiplying it by something else, by some number, a scalar quantity, and that's going to mean that the two vectors are parallel to each other. So really, really important to remember those two things, that we've got, if the dot product is 0, they're orthogonal. If one is multiplied by a scalar quantity, then they are parallel to each other. And if none of those things are true, then they're neither. So determine if the following are orthogonal, parallel, or neither, and explain. I always want some type of explanation or supporting answer. So letter A, given vector u is 2, negative 3, and vector v is 6, 4. So what we're going to do is just kind of go through and see, are they orthogonal or are they parallel to each other? So let's start by seeing if they are parallel to each other. So to see if they are parallel to each other, we're going to take one vector, doesn't matter which one, I'm going to take v, and divide it by the other. So when we do that, if we get the same thing when we divide the x component here by the other x component, if we get a number there, so let's do that. So let's take 6 divided by 2. That gives us 3. And then I'll take 4 divided by negative 3. And that really just gives me negative 4/3. So did I get the same thing when I divided the second vector v by the first vector? No, so they're not equal. Therefore, that means they're not going to be parallel to each other. So in order to be parallel, we have to take this vector, one of the vectors, and be able to multiply it by a scalar quantity. And remember, when you multiply it by a scalar quantity, you would distribute it into it. So if I multiplied this by 4, I would get 8, negative 12. If I multiplied this by 3, I would get 6, negative 9. So since this number is not a negative 9, these are not parallel to each other. So now let's check to see if they're orthogonal. So I'm going to find the dot product of u and v. So remember, to find your dot product, you're going to take 2, which I got from right here, times 6, plus negative 3 times 4. And a dot product will give you a scalar quantity. So 6 times 2 is 12, negative 3 times 4 is negative 12. So 12 minus 12 is 0. So therefore, we'd say they are orthogonal because the dot product is equal to 0. So that's what I'm looking for with your explanation. So your dot product is equal to 0, which means they're orthogonal. Let's do the next one. Let's call this letter B. So u equals 1, 4, and v equals negative 2, negative 9. So to check to see if they are parallel to each other, we're going to divide one vector by the other. So I'm going to take negative 2 divided by 1. That gives me negative 2. So now I need to take negative 9 and divide it by 4. And that just gives me negative 9/4. These are not equal. Therefore, they're not parallel to each other. Now let me find the dot product. So the dot product of u and v, actually pause the video here. You guys should be able to do this now. So pause the video and find the dot product of u and v. All right, so you should do 1 times negative 2 plus 4 times negative 9, which is negative 2 minus 36, which is negative 38. So here I would say these are not orthogonal because u dot v does not equal 0. So since they're not parallel and they're not orthogonal, we would say these are, therefore, doing a lot of therefores today, neither, because u dot v does not equal 0. They're not orthogonal, and u does not equal k times v. So they're not parallel and they're not orthogonal, therefore they're neither. And then just giving some type of explanation. So here they are orthogonal because the dot product equals 0. Here they're neither because the dot product does not equal 0. And when we multiply one vector by a number, a scalar quantity, it doesn't give us the other vector. All right, let's do letter C now. So we'll continue. U is negative 12, 30. And v is 1/2, negative 5/4. So they are fractions, which makes it a little bit more challenging. But I'd like you guys to try this on your own, even though it is a little more challenging with the fractions. See how you can do on your own, and then check back. All right, so let's check to see if they are parallel to each other. And I think this is probably the hardest part because we have the fractions here. So what I would do here is say, all right, let's do negative 12 divided by 1/2. Now I know when I divide by fractions, I can keep, change, flip. So I'm going to do that. And of course, if you have access to your calculator, you could type this in, but let me do it by hand first. So negative 12, keep, division change to multiplication, and then 1/2 would flip to become 2. So that gives us negative 24. Then here, I took negative 12 first, so I need to take 30 first, divided by negative 5/4. Keep your 30, change, and flip. And then you can reduce those. 5 goes into 36 times, which gives me negative 24. And we'll see that these are equal to each other. So since they are equal, we can say that therefore they are parallel to each other because we can take one vector and multiply it by the other. I'm okay with you saying this reason. If you want to be a little bit more specific, you could say vector u, if we multiply v by negative 24, it would give us u. So you could say also u is equal to negative 24 times v. But either way is fine. You can just leave it as u equals kv. I just want to know that you realize you can multiply by something. Oh, I was going to show how to do that in your calculator. So here I could type in negative 12, a couple different ways actually. Let's do alpha y equals. So let's do negative 12, and then in the bottom you could do alpha y equals even again. And that'll give you negative 24, or you could do negative 12 divided by 0.5 or 1/2 gives you negative 24. So a couple different options there. Even alpha y equals negative 12 over, and then you could do your 1/2 there. So a bunch of different ways of setting it up in your calculator. But what we need to know is that they are parallel because we end up getting equal quantities there. Now, let's just run through real quick, finding the dot product to make sure that they're not orthogonal as well. So take a moment here and find the dot product of u and v. All right, so you should have had negative 12 times 1/2 plus 30 times negative 5/4. So that would give us negative 12 times 1/2 is negative 6, and minus, and you can cross reduce here. That 2 goes into 4 2 times, 2 goes into 30 15 times. So that would give us negative 75/2. Add those together, you could get a common denominator by multiplying this one by 2/2. Which means we'd have negative 12/2, which would give us negative 87/2, or negative 43.5. So that is not equal, the dot product's not equal to 0, so they are not orthogonal. So again, always just checking to make sure you've covered all your bases. All right, let's look at a little bit different setup here. Let's find the value of k so that the vectors u and v are orthogonal. So again, I want you to train your brain to be thinking orthogonal dot product equals 0. So vector u is I, so it's given as a linear combination, I plus 4j, and v equals 2ki, so k is a constant, minus 5j. All right, so we know orthogonal means that our dot product has to equal 0. So we know our vectors here, u and v, We're just missing this k right here. So we can set up our dot product, set it equal to 0. And let's see where that brings us. So these, if you need a little refresher here, this is in component form. You would take the coefficient of I, which is a 1 and a 4. Here, this one, we take 2k and negative 5. So everything that comes before the I and then the j. So, and you don't need to rewrite these, but if that helps you, then go right ahead. So now I'm going to take 2k times 1 plus negative 5 times 4. And I know that this is my dot product, and if I want them to be orthogonal, then that dot product has to equal 0. And now I'm just going to solve. So pause your video here and solve for k. So you'd have 2k minus 20 equals 0. Add over my 20, and k equals 10. Try another one. So find the value of k so that the vectors u and v are orthogonal, and assume vector u is 3i plus 2j, and vector v is 2i minus kj. Pause the video here and solve for k. All right, so you should have found your dot product. So 3 times 2, and then plus 2 times negative k. Set that equal to 0 like we did up here. And then solve for k, and k should equal 3. So in your papers, I should see that you've solved this equation and gotten k. I don't want to see that you just wrote k equals 3. I want to see your work for that one. All right, and now I'm going to give you just a couple practice to do. So number 4, I want you to determine whether these vectors are orthogonal, parallel, or neither. So vector u is 8/5, negative 7, and vector v is negative 2/3, 3. So I gave you some fractions to try out there. Pause the video and determine whether these are orthogonal, parallel, or neither. All right, so you should have found that divided the two by each other, and you do have some fractions here. So you can always check that in your calculator to do it by hand. If you're dividing negative 2/3 by 8/5, you could do keep, change, flip, and then reduce those. So here 2 goes into 8 4 times. So you would get negative 5 if I multiply across the top over 3 times 4 is 12. And then on the other side, you would have done 3 divided by negative 7, which would give you negative 3 over 7. And those are not equal, so they're not parallel. So you should have written out that they're not parallel because u does not equal a number, a scalar quantity times v. Then you also should have found that your dot product was not equal to 0, and it does give you a large fraction of negative 3/31 over 15, and we know that that does not equal 0, which means they're not orthogonal, so your answer here would be neither. And again, I would expect to see a reason. So because your dot product does not equal 0 and u does not equal k times v. Right, and let's do another one here. Let's try vector u is 8 negative 4. and V is 5, 10. Determine if those are parallel, orthogonal, or neither. Pause the video and do that right now. All right, and I should see work on your paper, but your final answer should be that they're orthogonal because your dot product should have ended up being 0. Okay, and last one for practice we'll do, find K so that U and V are orthogonal. So U is Ki minus 2j, vector V is I plus 4j. Pause the video and find K so that they are orthogonal. Again, you should have found that your dot product is 0. If you needed to rewrite these, this would be K and -2, and this one would have been 1, 4. Find your dot product, set it equal to 0, and K would equal 8. All right, and that's it for these notes for today. And then you have a practice assignment that's a little bit of review of our notes that we've done. And if you have any questions at all, be sure to let me know. Make sure you're staying on top of everything you need to and getting help as soon as you need it. All right, I hope you guys have a great day. Pie out.